In our last section on vectors, we're going to talk about the cross product. The cross product of V and W, and we're looking at it in space, but if it weren't in space, we just wouldn't have the K component. So cross product is this. So, and we use this X here. That's not times. It's not an X. It's the cross product, okay? Anyway, so cross product of V and W is B sub 1 times C sub 2 minus B sub 2 times C sub 2. No, it's not. That should be a 1. I'll make sure I change that on your notes. So it's, let's start over. B sub 1 times C sub 2 minus B sub 2 times C sub 1. Okay? Hoping you'll start to see a little bit of a pattern here. And there's an easier way to do the cross product that we'll look at in a minute. Well, I don't know if it's easier, but it's a little more straightforward about not having to memorize this. And then minus A sub 1 times C sub 2 minus A sub 2 times C sub 1. And then plus, very important, minus and then plus, A sub 1 times B sub 2 minus A sub 2 times B sub 1. So you're kind of getting each cross in there. And like I said, we'll look in a minute at an easier way to keep that in track. So example 1 wants us to find the cross product of V and W. So we start with B sub 1 times C sub 2. So 2 times 4 plus, and then we've got B sub 2, that's 3, times C sub 1, that's 9. Okay? And then minus next is A sub 1 times C sub 2 plus, or is that minus? Oh, both of those are supposed to be, that's supposed to be a minus. That's supposed to be a minus. Sorry. Okay, minus A sub 2 times C sub 1. So 2 times 9. And I need to put my I and my J in here. Then plus A sub 1 times B sub 2 minus A sub 2 times B sub 1. Okay. So yeah, that's a lot to remember. But you don't have to memorize it. You can use it, the formula, on your test. So that'll be 8 minus 27I minus 24 minus 18J plus 18 minus 4K. Simplifies to negative 19I minus 6j plus 14k. So this is the cross product, V cross W. We're going to talk about something called determinants. And the cross product can be done with determinants also. And it's a little bit easier to see it with determinants. Here's the reason. So determinants is if we kind of make a matrix where you've got your first vector here and your second vector for the second row. And you find the determinant by multiplying in a cross pattern like this. So there's your a sub 1 times b sub 2 and your a sub 2 times b sub 1. So if you do a 3 by 3 determinant, you've got A, B, and C on top, or in most cases for us that'll be I, J, and K. Then your first vector in the middle, in the second row, and the second vector in the third row. Then here's how you make your determinant. Okay, so starting with A, we do this. A times this, the determinant made with B1, C1, and B2, C2. Hopefully you'll see what I'm talking about here again. Then we've got our minus. We still got minus. Cross out the B column across the top. Then it's B times the determinant made with these four. See how we crossed out that column and you use the other two? And then plus, cross out the C column, the determinant made with this. Why does it make it easier for us to do the cross product now? Because if we remember what the determinants are, which is a little bit easier than trying to pick out B sub 1, A sub 1, all that mess, then we're just multiplying across each way each time. So let's look at an example of that. For example 2, we're just evaluating the determinant. So all we do is 2 times 4 minus 9 times 3. That's 8 minus 27, or negative 19. That's also the cross product of the vector with 2, 9, and 3, 4. If we want the determinant for this one, first, cancel out A. So we have 2, 9, 3, 4 times A minus, cross out B's, we've got 6, 9, 2, 4 times B plus, cross out C's, 6, 2, 2, 3 times C. Then 2 times 4 is 8, minus 9 times 3 is 27. Six times 4 is 24, minus 9 times 2 is 18, plus 6 times 3 is 18, minus 2 times 2 is 4, C. So we end up with negative 19a minus 6b plus 14c. So if we're trying to find the cross product, we can just do this. And I personally think it's a little bit easier to remember than that first back here. Okay? And here it is written out. You just put I, J, and K up top and go forward just like we did in the example to find the cross product with determinants. The big catch to remember is you got minus and then plus. Example 3 says if, give me 1 second, wrote down something wrong. If you've got these two vectors, find v dot w. And this time we're going to use the cross product to help us. Or we're going to use our determinants to help us. So we'll have I, J, and K on the top. Then 6, 2, 9, 2, 3, 4. So, first, with I, we cross out, and we're left with 2, 9, 3, 4. Minus. Then with J, we cross out, we're left with 6, 9, 2, 4. Plus, cross out K's, we're left with 6, 2, 2, 3. Okay. And then we go through like we did before. 2 times 4 is 8, minus 3 times 9 is 27. I minus 6 times 4 is 24, minus 9 times 2 is 18, J, plus 6 times 3 is 18, 2 times 2 is 4, so minus 4, K. And if you'll notice, this is the same as the last problem. We get negative 19I minus 6J plus 14K. The algebraic properties of the cross product: if you cross a vector by itself, you get the zero vector. U cross V is the same thing as negative V cross U. So the property isn't U cross V equals V cross U for cross product. It's negative V cross U. You can distribute no, it's not really distributed, is it? So if you find the cross product of U and V and multiply it by K, that's the same thing as multiplying U by K and then cross product with V, or multiplying V by K and cross producting with U. Then this is true. U crossed with V plus W is the same as U crossed with V plus U crossed with W. Geometric properties of the cross product. So what does that mean for us in space or in the plane? If you take the cross product of u and v, then that cross product, that vector, is orthogonal or perpendicular to both u and v. If you take the magnitude of the cross product, so look at this second one here, then that is the same as the magnitude of u times the magnitude of v times the sine of theta, where theta is the angle between u and v. Also, the magnitude of u cross v is the area of the parallelogram having u and v as adjacent sides. So that's interesting. And then if u cross v is 0, then u and v are parallel. So example 4 asks us to find a vector that is orthogonal to u and v. So if we look back here, if we find the cross product of u and v, then we're finding the vector that is orthogonal to u and v. So we're finding u cross v. And I'm going to do this with determinants again because I think it's easiest this way. So ijk across the top, then 6, -2, 9, 5, 1, -4. Okay, just looking to see if I had extra space. So cross out I. We're left with -2, 9, 1, -4. Times I minus, cross out J. We're left with 6, 9, 5, -4 times J plus, cross out K. We're left with 6, -2, 5, 1 times K. So we got -2 times -4 is 8. Minus 9 times 1 is 9. Minus 6 times -4 is -24. Minus 9 times 5 is 45. J plus 6 times 1 is 6. Minus -2 times 5 is -10. K. So taking that to the next page, we get -I plus 69J plus 16K. So this is the vector that is orthogonal to both U and V. We can check that, and we will very quickly. So to check and see if two vectors are orthogonal, if they're orthogonal, then the dot product, if you'll remember, is 0. The dot product, not the cross. So if we take U and dot it with -I plus 69J plus 16k. Remember, the dot product is six times, we've got u, so 6 times negative 1. That's a negative 1, plus negative 2 times 69 plus 9 times 16. And the 6, the negative 2, and the 9, that came from u. u was 6i minus 2j plus 9k. Okay. So that gives us negative 6 minus 138 plus 144, which is 0. We also need to check v dot our supposed orthogonal vector. And you don't have to check these unless you're asked to. V is 5i plus j minus 4k. I'm just showing you how to check in case you are asked to test for these being orthogonal. So let's see, we've got 5 times negative 1 plus 1 times 69 plus negative 4 times 16. That is I've got something written wrong on my paper, but negative 5 plus 69, 4 times 16. I don't have this written correctly. Let's see. 4 times 6 is 24, so yeah, 64. That's a negative 64. And yeah, we do get 0. For our last example, we are going to use the area of a parallelogram, the fact that it is the cross product of two adjacent sides of the parallelogram. So if vector v is one side and vector u is another adjacent side, then it's basically the cross product of the base times the height, the cross product of u times v. And then take the magnitude of that, and that gives us our area. So find the area of this parallelogram. We've got 4 points for this parallelogram. We need 2 adjacent sides. So one side, we'll call it u, would be the vector from P1 to P2. Another side, which we'll call V, could be the vector from P1 to P3. Okay? So as long as we start, you could have chosen P2, P1, and P2, P4. As long as you start with the same point for both of them. Well, P4 would be over far away. So, yeah. Anyway, this is what we need to do. So, to find u, vector u, then we need to find the vector from P1 to P2. And remember how we do that? We take each A, B, and C here, X, Y, and Z, and subtract them. So 5 minus 1, I, plus negative 4 minus 1, J, plus 3 minus 1, K, will give us U. That'll be 4I minus 5J plus 2K. Then P1 to P3, that would be negative 3 minus 1. I was doing negative 3 minus 1 here, okay? I plus 5 minus 1, J, plus negative 3 minus 1, K. Gives us negative 4I plus 4J minus 4K. So that's our first step. Our next step is to find the cross product between those. So let's write down what U and V are over here again. Okay, so we need the cross product U times V. So we'll use the determinant again. I, J, and K will go across the top. Then U is the second row, and V is the third row. So we have, cross out I, we've got, we'll go down here, negative 5, 2, 4, negative 4, I, minus, cross out J, 4, 2, negative 4, J, plus, cross out K, 4, negative 5, negative 4, 4K. Okay? And then cross. So negative 5 times negative 4 is 20. Minus 2 times 4 is 8. 4 times negative 4 is negative 16. Minus 2 times negative 4 is negative 8. 4 times 4 is 16. Minus negative 5 times negative 4 is 20. That gives us 12I minus 8J plus 4K. Now, I've just found the cross product of U and V, but to find the area, we need to find the magnitude of that cross product. Okay, so the magnitude is the square root of, looking up here, 12 squared plus negative 8 squared plus 4 squared. That's the square root of 224, which simplified is 4 square root of 14 square units, whatever our units are. And you could change that to duodecimal if that's what it asks for. But that finally concludes our chapter on vectors.